Okay, guys, I'm going to go over lesson 3.2. All right, so first of all, these are all solving systems. Some are going to do algebraically, where you're going to do it out by hand, and some are going to do on a graph. So we may be using Desmos in some case to do the graph ones, depending on what's going on. Okay, so first of all, starting out with this one. Here, I've got a standard form equation. This is standard form. I know it's standard form because I have x and then y, or at least two variables in a row, right? And then there's a constant or a number on the other side. If you look at this next one, on this side of the equal sign, I've got an x, and over here, I've got a constant in the number. So that's not quite in standard form, but it's set to x, okay? It's set to x. And the reason I say that is because x is by itself here. So what I can do is I'm going to take that and substitute into the other equation. So I'm going to set this up for you. So we'll plug in all of that because it's equal to x into here. So a minus 3y. Don't forget to rewrite the entire equation. So don't forget that 6y there. Sometimes people forget that. So now I'm going to go through all these steps, right? I'm going to distribute that. I'm going to combine like terms. I'm going to subtract, and then I'm going to get y. Okay, so you're going to have to solve that. Now, once I get y, I need to find x. Because remember, when you're solving a system, you're solving for y, x and y. You're looking for a point or a coordinate. Okay, so now I'm going to take that y, and then it's going to be plugged into another equation. I can plug it into either one. The easiest one to do would be this one because it's already set to x. So basically, when I find x, I'll take that equation. And once I find that number here, I'm basically going to plug it in there. Okay, and multiply it times 3. And then subtract that from 8. Okay, so that will get your solution. And then when you finish all of these problems, okay, when you're solving a system at least, then you're going to write out your answer as a coordinate. So make sure you finish like that. Okay, so now for the sketching the graph, what you guys can do is that you can actually just go to Desmos and say, like, let's say I got, I don't know, like two, I'll just type the equation, okay? So I got 2x plus 6y equals 10. All right, so there's that graph down there. Okay, and then the other one is x equals 8 minus 3y. All right, so there's the other graph. Now I want you to take a look at these graphs, okay? Notice how they pretty much have the same slope. If they got the same slope, you guys remember what that means? They're parallel, meaning they will not intersect. They will never touch. So that means you're not going to have a solution. Okay, so if I'm going back here, first of all, I'm going to make a quick sketch of both of these graphs. I'm going to kind of do my best to look at Desmos here. Looks like, that's a little below 2 there on that intercept. So I'm like, here, I'll mark that right below 2. And the other one, it's right above 2, right before 3. It's about right there. So then what I'll do is I'll take a straight edge or some kind of ruler. Right, and I'm going to do my best to kind of copy what I see. Okay, what I just want to make sure is that they do not touch each other. Oops, pencil just broke. Okay, I put my arrows on the end, make it neat. Okay, and I could do a little bit more. What I could do is I could get actual points. Like here, I've got an actual point at, let's see, 2 and 2. So that would probably be helpful. I could take that point there. And then there's an actual point at -4 and 4. And actually, honestly, that's probably a better idea. Let's actually do that. Let's get actual points instead of just kind of guessing here. Okay, so I'm going to put 2, 2, and then the other one was at -4, -4. Okay, so there's a line. Remember, a straight line, you only need 2 points. All right, and then on the other graph, let's see, what do I got here? I got to find a point that's, oh, that looks like there's one at 2, 1. And it looks like there's one at 5, 0. So 2, 1, and 5, 0. So 2, 1, and 5, 0. Okay, I guess I was pretty close. Okay, so there we go. And then I'm going to put my arrows in the end. All right, so again, how does the graph of the system explain what happened? Okay, well, when you solve this, you're going to see something, okay? And it's going to explain what happened when you solved it. And notice that they don't touch, so there's no solution. parallel lines, sorry, that's terrible, have no solution. But they do have the same slope. Okay. So you're going to notice something as you're solving this, that you're going to end up with variables canceling out. Okay. So now in this next one, now I'm going to take this equation, okay, and I'm going to solve it graphically, numerically, which means I'm going to create a table, and algebraically, which means I'm going to solve the equation step by step. Okay, so I want you to know though, I know this looks like just one like weird looking equation, but this is actually two separate equations here. Okay, the first one is y equals x minus 3 squared minus 2. You might recognize that in as graphing form. The second one is y x equals x plus 1, and that's y equals mx plus b form. So that's a parabola, and then that's a linear function or a straight line. So that way I know kind of what I'm expecting on this graph. Okay, so the easy one to graph is the x plus 1, because it's mx plus b. So I'm going to go up to, I'm going to draw on a few marks here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so I start at 1. Okay, then the slope is up 1 over 1. So up 1 over 1. Up 1 over 1. Yeah, I'll probably just do like one more. Up 1 over 1. Okay, take my straight edge because it's a straight line. Great. Now I know this is a parabola, so that's a u, and my vertex point is going to be 3 and minus 2. Remember, x is a liar, so it's positive 3. So now I'm going to have 3 minus 2. Okay? So now what I'm going to do is now make my u going this way, make my u going this way. And honestly, I don't know exactly where they line up. Okay? But it's going to be somewhere about here and somewhere about here. Okay? So it looks like, you know, notice how it says if possible, right? So it's kind of hard unless I get like the exact graph. So I could put this on Desmos. I could put this on Desmos and basically type those in. Okay, so let's go ahead and do that. So here I get x minus 3. Go down here to the calculator and turn on the square. Minus 2, and then x plus 1. Okay, so then here I can see there's a solution, and there's a solution. So there's a solution 1, 2, and 6, 7. Okay, so it's actually a little bit closer to here, which means my graph's just a little bit off. So I probably want to make it kind of curve up like that. And you can double check all these things with Desmos. Okay, so now that I know the solutions, I know that the biggest x value for the solution is 1 and the smallest is 6. So when I make the table, I'm going to consider that. So I'm going to go from 1 down to 6. And I'm going to show you an easy way to get the numbers for this table. Okay, so for the left, I'm going to put that function, the x minus 3 squared minus 2, and then the x plus 1. Now, x plus 1 is pretty simple. X plus 1, 2. X plus 1, 3. X plus 1, 4. X plus 4, 5, 6, 7. Hey, and there's those points. This one's not as simple. So what I'm going to actually do is I'm going to use Desmos to make a table. So I click here, and then what I'm going to do is click Add Item, Table. And what I can do is I'm going to type in those same numbers. So 1, 2, 3. And you notice it kind of like starts to automatically fill them in. And then up here, what I have to do is type the equation. So this equation up here, I'm actually going to type that out. Let's see if it'll actually copy. I can copy and paste it. Oh, sweet. Okay, now you notice it's not giving me anything, right? So the reason for that is because I have to put this little number after the x. It's called a sub number because it's below. If I type that, boom, they show up. Okay, so there's all the values. So I'm going to copy those into my table. 2, I'm copying this down right now. Maybe you guys can do the same. Okay. All right, so now I've got them all copied down here. And so you can see that there's the points that kind of line up and that are an intersection. Okay, so I can use the table, I can look at the graph different ways. Now, the last one here, algebraically. Well, algebraically, I'm going to leave this as equations which is equal to each other. Okay, but before I do that, notice how it's squared up there. So I'm going to have to expand that. Now, I'm not going to show you all the steps for this one. You're going to have to finish the rest. But here, I'm going to have to multiply this out. So I can use the box, multiply that out. Now, you know, as a teacher, I know this one. So I'm going to just do x squared minus 6x plus 9. So after you do the box, you end up with this. And then there's a minus 2 after it, x plus 1. Now I have a squared, x squared. So what that means is I'm going to need to get this equal to 0. Okay, and then factor it. Okay, so to get it to equal 0, I'm going to subtract this from both sides. And notice here I've got 9 minus 2 and minus 1. So I'm going to have to kind of add this minus 1 in there. So 9 minus 2 and then minus 1. Okay, so then I'm going to get negative 7 here. That's going to be plus 6 there. And it's your job now to figure out the rest. So what you're going to do is you're going to figure out what x is. Right? But that's not enough. It's a system, remember? It's a system, which means there's a y value, not just an x value. So what you got to do is take that number and plug it back into one of the equations. And the easiest one to do that is your y equals x plus 1. Because all you got to do is take that number and add 1 to it. So I take this number, I add 1, and then that's going to give me my solutions, or my y value to the solution. Okay. So whatever you guys come up with here for x, that's going to go here. And then after you plug it back into one of the equations, or this one, you're going to basically add 1, and that's going to give you your y value that goes here. Okay. All right. So now on this one, we want to do it graphically. So we can basically kind of do it the same that we did up here, except I probably want you to use Desmos. Go ahead and use Desmos so you can get more of an exact graph. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. In general, most of these you just need about 5 marks and you're good. Okay, so this one's pretty easy to graph. So again, these are two separate graphs. You got an absolute value and then a linear. So I'll start with this one. So minus 3. And then up 2 over 3. Up 2 over 3. Okay, that's good enough for me. Whoop. Actually, I could go down 2 and then over 3. So it's about right there. Okay, so now that one, let's go to Desmos to figure that out. Okay, and actually what I'm going to do is I'm going to jump over to here to the numeric. And the reason for that is once I get these points, I can just plot them on the graph. So let's finish this, and then we can use that to help us finish the graph. Okay, so we'll basically go over to Desmos. Close these out now. I have 2 absolute value x minus 4, and then minus 3, and then the other one's going to be 2 divided by 3, x minus 3. Okay, so here, let's start with this guy. And I've got a point here, got a point here, got a point here, got a point here. Look at all those great points. Okay, so I'm not going to use all of those. Okay, but let's see. I've got, looks like a solution at 3, 1 and 6, 1. So that means my x values I need to have at least 3 and 6 in there. Okay, and I'm probably going to use the 4 as well. So let's go like this. Let's go 3, 4, 5, 6, 7. Just want to make sure to include all those important points. Okay, so let's go back. So now for the v, or the absolute value, I've got this point at 3, negative 1. So I'm going to write that in right there. And that's also going to be the same for this one because that's where they intersect. Okay, let's go back. Okay, now here, this is the absolute value at 4 minus 3. So again, absolute value of 4 minus 3. It's not going to be the same for this guy. At 4, this is equal to like negative 0.33. Negative 0.33. Okay, let's go back over here. Okay, so now for the absolute value at 5, which is about right here. Let's see if I can get this to move until I get to 5. It's negative 1, 5, negative 1. Okay, so that is that's the absolute value graph. Okay, for this line, to get to 5, let me turn. Let's see if I crawl along here at 5, it's 0.33. See that? Okay, so 0.33. Okay, let's go back. And then at 6, that's our next solution. So they both are going to be the same there. So 6, 1, 6, 1. And then for 7, starting with the absolute value, at 7 lines up right there at 7, 3. So I'll put 7, 3 here for absolute value. And then for the linear line, right there at 1.6, we'll round that to 1.67. Okay. Okay, so when you're use Desmos to figure out all these values, that way you don't have to plug in every value and figure out what that is. Okay, so there's the where they line up. And now we're going to use that to help us finish this graph. So I already got this line, so I need these points to finish the absolute value graph, the V. So here at 4 minus 3, that was that point where it's like the vertex, okay, the middle of the graph. Okay, so I could put a line of symmetry there, and then I have 5 and negative 1, okay, and then 3 and negative 1, and that's really, guys, that's all I need for absolute value. I just need those 3 points, and I can kind of sketch it out, okay. And there's a solution. There's a solution where they cross. Algebraically, okay, this is going to be a little bit different. So now I got 2 times x minus 4 minus 3 equals 2 over 3x minus 3. Okay, this is going to be a fun one. Okay, so now I want to approach this like I do a lot of other equations, where if I have a number over here, I'm going to take that away from both sides. Plus 3, plus 3. And a good thing that cancels out, so that helps me out a little bit. Okay, so 2 times x minus 4 equals 2 over 3x. And I want to get rid of this 2 first. So I'm going to divide that by 2. Okay, so because I'm dividing by 2, what's going to happen here is the 2 on the top, 2 on the bottom cancel. So that works out nicely too. That cancels. So now I just have x minus 4 equals 3x. Sorry, 3x like that. Okay, so now oops, sorry guys. Okay, so I get 3x there. All right. All right, so now what I have to do to solve an absolute value equation is I have to split this up. Okay, so first I do x minus 4, and then I make that number negative. I'm sorry, I keep it the same, make it positive. And then I'm going to do it again, x minus 4, and then the number to the right now becomes negative. Okay, this was shown in some of the previous lessons. Okay, so now I'm basically going to solve both of these. Okay, so basically you want to solve both of these, and you're going to get one x value, another x value, and guess what? It should match up with these here. And in order to get the y value, then you have to plug it back in to one of the equations. So for y, plug back in to one equation. Okay, so you can plug it in either to the 2 times x minus 4, absolute value of that, minus 3, or 2/3 times x minus 3. So one or the other you choose and plug it back in, and you'll get your y value. Okay, so now on the ones on the bottom, again, it's more solving systems. Okay, this is elimination. So you can set up your elimination problem. Okay, now remember you need them to be opposites, right? When they be the same number, but opposite signs, and these are the same, but then they're both positive. So what I'm gonna do is I'm gonna take the top one and make it all negative, okay? So multiply negative all the way across. So now I have negative x. I'm gonna rewrite it that same one down here. Then negative 2y equals negative 17. Okay, so now that cancels. I get negative 3y. Now 2 plus negative 17 is negative 15. Then you're going to get your y when you divide there. And then to get your x, I would take the easy equation like this one and just plug in that y. So maybe we take that number, plug it in there, and then solve for x. And then you'll get your solution. Okay. Now this one, okay, this one is also going to be a standard form equation. But the problem with this one is that I've got like I've got variables and constants on both sides. So let's get them all on the same side. So here, I'm going to add 2x to both sides. And the constant, remember, when you're doing elimination, you want to stay on the right, so I don't have to do anything with that one. Okay, so what I end up with here is, oops, sorry, not 2x. 2x plus 2x, so that's 4x. Then plus y equals 5. Okay, then here, I'm going to subtract 2x and subtract 3y because I don't want any variables on the right. So that means I'm going to have 0 on the right, which is fine. You can have 0. Okay, so then I'm going to have x, 2 minus 2, and then 2 minus 3 minus y. Okay, so now I can set it up, eliminate, and then solve for whatever, I think you're going to end up solving for x first and then find y. Okay. Okay, now on the back side. Okay, so you got this quadratic equation here. Let me move this over so you guys can see. Okay, so I got the quadratic equation, x squared plus 5x minus 6. Question is, where does the graph of y equals p of x, which is this one, intersect the y-axis? Well, I want you guys to think. Points that intersect the y-axis, what's that called? That's called a y-intercept. And if you guys remember, the y-intercept on a quadratic equation just comes from this number on the end. So basically, it's just 0 minus 6. Simple. Okay, where does the graph of y equals p of x intersect the y-axis? Oh, oops, I think that's supposed to say x. So not the y-axis, but the x-axis. Okay, so in order to get those numbers, the x-intercepts, that's not so easy. Okay, so here I'm actually going to have to factor this out using the x and the box. Okay, once I get that, okay, x minus or plus or whatever you're going to put there, right? Okay, your answers that you get from that will be your x-intercept. So you're going to have to work this out. You guys have done these a bunch of times. Okay, and then you'll have to find those x-intercepts. And remember, your x-intercepts, your y is 0. So just basically whatever number you get from here, you take the opposite. So if that's like minus 3 or whatever, then you put positive 3. If that's positive 2, then you put negative 2. Okay. Now here, q of x is x squared plus 5x. So what are the intercepts here? So it's asking for both the y and the x. Well, same thing for the y-intercept. It's that third number, but there's not one written, so it's basically just 0. So 0, 0 is your y-intercept. So that one's easy. X-intercept, a little different, not too bad. Here, I'm going to factor this. Now it's just two numbers with x. So what I'm going to do is do q of x and factor out an x from both. And then I end up with this. So if you guys remember, this is when you use the 1x2 box, one like this, right? And then from that, you're going to get your first x-intercept. And from that, you'll get your second x-intercept. Remember that the y is going to be 0 there. Okay, now compare the graphs. Well, I want you guys to take a look. Notice how this is x squared plus 5x minus 6. And this is also x squared plus 5x. It just doesn't have that minus 6, right? So if the y-intercept is in the middle at 0, 0, and the y-intercept of this one is at 0, minus 6, think about it. All that's really happening is that from this graph, let's say I'm going from this graph to here, or let's actually start from here. Let's say I'm going from this graph, 0, 0, and then I'm going to 0, minus 6. It's basically 6 units apart. So in other words, p of x is 6 units lower than q of x. And if you put that on a graph, you would see that. Now, what is p of x minus q of x? Well, that's what you're going to have to figure out. You take p of x, which is the first one, and then subtract from that q of x. Now, notice I put this in parentheses because you're subtracting the whole thing. So that means you're going to have to distribute the negative. So you figure out what that is. All right? So I'm going to write this here. P of x minus q of x equals what? Okay, you figure that out. All right, down here, more systems. Okay, so this is y equals y equals. So really all you got to do, guys, here is set up them equal to each other and then solve. And notice how you're going to solve for x first, right? Okay, and then plug in and find y. So I'd probably take maybe that equation, this one, and I'm going to take that x and then plug in for y, and then I'll get my solution. Okay, and then you want to describe that. Does it intersect at 1 point, 2 points? Okay, is it all real numbers where they overlap? Okay, where you got two lines on top of each other? Okay, or is there no solution? Or they don't intersect at all? Okay, you got to decide that for each of these, okay, based on what's going on. Okay, now this one, I'll help you out here. I noticed that this one's in standard form. This one's close. I got a choice here. I could try to put this in standard form, or I could substitute. I'm going to substitute just because y is almost by itself. So what I'm going to do is add 7 to both sides. And now this equation will be y equals negative 2x plus 7. And so what I'll basically do is take that and then plug it into y and then solve. So 4x plus 2 times negative 2x plus 7 equals 14. So now your job, you can see now you're solving for x, find x, and then plug in, once you get that, plug that x into here, and then you'll get your y. Okay, and again, write out your solution. Okay, now something interesting happens here that you'll notice after these first couple steps, that the variables are going to eliminate. You're going to have nothing left. And then you're going to have these two numbers equal to each other. So now you got to decide what was the solution based on what you ended up with here. Okay. All right, so now down here, again, another y equals y equals. So now we're going to set these equal to each other. Now, you guys have done problems that look like this in previous lessons. Okay, I'll do one of these, but then this one's very similar to that one. Okay, so now this one, what I want to do, as usual, is add the 5 to both sides. I'm trying to get that squared part by itself. And as I'm doing that, so 14x plus 22, okay? And then, make sure I'm still on here. All right, so now here I want to get rid of that too, so I'm going to divide that on both sides to each number. As I'm doing that, I'm going to expand this out because it's squared, so I have to write it out twice. This will be divided by 2, divided by 2, it's 11. And now what I would want to do is bring out the box and then multiply that. Okay. So now when I notice it's got an x squared, which means you're going to have to make it equal to 0, then factor it using the x in the box. Okay, when you get those x's, you're going to have to plug both x's back into one of the equations. So I probably use this one. So plug them back in to there, and then that way you can figure out what the y is for each of these, because you're going to end up with 2 solutions. Okay. Now here, it's going to be pretty much the same steps. Okay, you're going to pretty much follow the same methods and work it all the way up to the end. So this one will be the same. Okay.